Okay, Algebra 1 fans, our topic for today, this is Chapter 2, Section 3, Solving Multi-Step Equations. And after this lesson, students should be able to, while this is blank, I'm going to write it in, we should be able to solve multi-step equations. So that's more than one step. Before we start, let me give you your joke of the day. Why did the fish get bad grades? Because it was below sea level. All right, so as a warm-up here, we're going to do a quick review on solving one-step equations. So what I would do is pause this, go ahead and solve them yourself, and then press play and see if we get the same answer. Okay, so for number one here, I'm going to draw my line down from the equal sign to separate my left side, my right side. X plus 4, we are going to move. This is called the constant. A constant is a number by itself. And when I say by itself, it's not multiplying the x. It's separated from x by this plus sign, or it could be a minus. To undo addition, we subtract, but whatever we do to one side, we must do the same thing to the other side. So we get x, this is 0, so just x equals 8. And we know we're good because if we take 8 and we substitute back into the equation, 8 plus 4 is equal to 12. It works. In number 2, we have 4 times x is equal to 12. So now the 4 is a coefficient. That's a number that multiplies the x. To undo multiplication, what we do is we divide. But again, we must do the same thing to both sides. So 4 divided by 4 is 1. We get 1x, which is the same thing as x. You don't even need to write the 1 there. So x equals 12 divided by 4 is 3. And to check that, 4 times 3, does that equal 12? Yes, it does. Now, for number 3, you could do this in one step. I'm going to break this into 2. The first thing I'm going to do is rewrite this left side. I'm going to put the negative in the numerator. I'm going to write that as negative 3 over 4. Now, we have negative 3/4 times x. Well, that x is part of the numerator. If I want to write it that way, a lot of times we'll leave it next to the fraction, but in this case, I'll actually put it in the top of the fraction, is equal to 12. Because what I'm going to do first is I'm going to take care of the 4. So we have negative 3x divided by 4. To undo division, we multiply both sides. And what happens here, this is like a 4 over 1. 4 divided by 4, I can reduce that. That's just 1. And what we get is negative 3x is equal to 48. And now we undo the multiplication. We divide by negative 3 on both sides. And the reason we divide by a negative is we need to get a positive 1x. So a negative divided by negative is positive. 48 divided by negative 3 is negative 16. And to check this, I'll take the calculator this time. And so I'm going to type the original equation before I did anything. So it was the opposite of 3/4. And then times, you can put a time symbol, I like parentheses. My answer was negative 16. And what we should get from this, we should get the right-hand value, which is 12. And we do, so what that means is that our answer is correct. Okay, so that's a quick review on one-step equations. Now what you're going to find is multi-step equations are the same rules, it's just we have to do more than one thing. The first thing we always look for is to combine like terms. If we have like terms on one of the sides, we want to combine those first before we move anything. Okay, and then typically we're going to move the constant next, and that's by addition or subtracting it. Addition or subtraction on both sides. Usually the last step is to move the coefficient, the number that multiplies the x, and we do that by multiplication or division, both sides. And again, if you're trying to figure out which one to do, we do the inverse operation. So the inverse of addition is subtraction. The inverse of subtraction is addition. The last thing we always want to do is we want to check our answer or solution. We don't want to think it's right. We want to know that it's right, that it makes the equation true. All right, so examples. Let's take number 4 here and draw my line down. So we have 2x, 2 is a coefficient, plus 4, that's a constant. We are going to subtract that first. Remember that the goal is to get the variable by itself. Okay, so I want x on its own side. I'll keep it on the left side. I want to get x equals something. So I need all these other numbers to get over here. So I'm going to go minus 4. We get 2x. I copy that. 4 minus 4 is 0. So that's gone. Equals 12 minus 4, which is 8. Now 2 times x, how do we undo multiplication? We divide. And what we get is 1x equals 4. Okay, and then the check, I would take the left-hand side. I would do 2 times x. Now that was 4. And then add 4. We should get 12, and we do, so we're good. Number 5. Let's move the constant, which is the 3. Now, this is a positive 3. There's no sign in front of this. That is automatically a positive. So when I move a positive constant, I must subtract. The reason I know this is good is that 3 minus 3 is 0. I'm trying to make 0 from that. Now what that leaves, though, that's not 4x. That is negative 4x. That minus, that subtraction, goes with the next value. Equals 19 minus 3 is 16. Now, this is negative 4 times x. That's a coefficient. To undo that, we divide both sides by negative 4. We get 1x, positive 1x, equals negative 4. And check it. So now I'm going to type 3 minus 4 times, what was the x? Negative 4. We should get 19, the right-hand value, and we do. So we're good. Number 6, now before we start moving things, we have to take care of distributing. Okay, this 3 is next to parentheses. That is going to distribute. So 3 times 2x, 6x. 3 times 4 is positive 12. And now we'll move the constant, positive 12, we'll subtract it. And again, as you go through, the reason why we're doing this, 12 minus 12 is 0. Okay? If you did 12, if you did 12 plus 12, okay, I'm going to make a mistake here. 12 plus 12, that's not 0. That would be 24, and that's not what we need. We're trying to get rid of this positive 12. So we have to subtract it. There's the 0 pair. Equals, now negative 9 minus 12 is negative 21. We'll divide by 6. And we get a decimal, negative 3.5, or you could write that as negative 7 over 2 if you want. I like the decimal because it terminates, it stops. So that's what I'm going to go with. And, okay, my check. So I'll type 3, parentheses, 2 times our answer. I'll do a times symbol this time, negative 2.5, oh, negative 3.5, excuse me. Plus 4. Do we get negative 9? Yes. Okay. All right, now let's deal with some fractions. In this case, the variable is on the right side. So that means I'm going to move the constant to the left. The constant's a minus 1. We'll go plus 1. That's 25 equals 0 there. Now that's negative. I'm going to write this as 4x over 3. To undo dividing by 3, we will multiply by 3. 3 times 25 is 75 equals 3 divided by 3 is 1. So that's negative 4x. And then the last move here is divide by negative 4. Again, we're going to get a decimal. We'll get negative 18.75 equals 1x. Now, some of these you can check in your head, but as they get more complicated, you're going to want to use the calculator to help you. So now I'm typing the right side because that's where the x is. So negative 1 minus 4/3 times negative 18.75. Does it give us 24? Yes, we're good. Now let's see. Number 8. It's a good problem. 1x plus 2x plus 5x is equal to 48. Well, these are like terms and they're on the same side. So before we try to move anything, let us combine those and we get 8x equals 48. Now all we have is the coefficient. We'll divide by 8 to undo that multiplication. 8 divided by 8 is 1. So 1x equals 6. And so let's see, we had x plus 2 times x plus 5 times x. And does that give us 48? Yes, it does, so we know that we're right. And we'll do one more here in this first video. Now, in this case, you have this whole expression being divided by 4. Now, you could actually break this up if you wanted to. You could write this as 2 over 4 minus 3x over 4. But what I think is going to be easiest is to start by multiplying both sides by 4. And what happens here, I'm not going to distribute, I'm going to divide first. 4 divided by 4 is 1. And then 1 times this is just this, 2 minus 3x back, equals 5 times 4 is 20. Now we're going to move the constant, which is a positive 2, by subtracting it. So we get 0 minus 3x, negative 3x, equals 18. And then we'll divide by the coefficient, which is negative 3. And we get x equals negative 6. So I want to know that that's correct. So the fraction on the left side was 2 minus 3 times negative 6, all divided by 4, and we should get an answer of 5 on the right side, and we do. Now, I'm going to go back to one problem here. I'm going to go back to number 7, and you might say, well, wait a minute, in number 9, we multiplied first, but in number 7, we actually did the plus 1 first. Could we have multiplied? The answer to that is yes. I'm going to rewrite it over here. If you wanted to get rid of that denominator, that fraction, we could have done it by multiplying both sides by 3. However, you have to be really careful because this is 72. I would have to distribute the 3. 3 times negative 1 is negative 3. Negative 4 over 3x times x times 3 would be minus 4x. So I could do that. What people always forget, though, is they have to multiply the 3 by all the terms here. They forget to distribute. So to avoid that, that's why I moved this first. We couldn't subtract 2 because the 2 is also being divided. In this case, the minus 1 is not being divided by 3, so that's why we can move that. But if I did solve it this way, I would then add 3. Here's 75 equals negative 4x, which is exactly what we have here. And then we divide, and we end up with the same answer. Okay, so you can do that, but I would avoid this situation. The only time I would multiply to begin is in this case where everything is being divided by that value. And that is the end of part 1.